Okay, first of all, welcome to my channel Inayatali, and today I'm going to tell you the topic nitrogen vacancy center in diamond. So, what is nitrogen vacancy center in diamond? And let's introduce NV center. So NV center is a point defect in diamond lattice, and in a lattice of diamond there is a nitrogen and there is a vacancy which can be generated. So why it is important? It is important because in quantum material world it's due to photoluminescence. What is photoluminescence? It's actually electron absorb energy and produced a photon. So due to its energy difference, the photon is emitted, and that photoluminescence can be manipulated through a magnetic and electric field. Before going to that, let's discuss four quantum numbers. So first one is principal quantum number, the second one is orbital quantum numbers, and third one is magnetic, and the fourth one is spin quantum number. And the fourth one is very important for us because of our application. So Pauli exclusion principle said that two or more identical cannot occupy the same quantum state. Means these quantum four states cannot occur at the same time, two or more than. So let's discuss further. So we are focus on this spin quantum numbers. So actually it is the rotation of electron. One is spins up and other is spins down. So these are the two property and which can also be used as a qubit, as you know that in qubit one is 0 and other is 1. So two states. So what is the structure of electronic structure of the NV center? Actually NV center have, if they have 0 charges, it means they have 5 electron, 2 from nitrogen non-bonded lone pair and 3 from covalent bond with a carbon. You can easily see. If we apply the external voltage, so what happen? It get excited and it's have minus charges, means now 1 electron added to that nitrogen vacancy center. Now it have 6 valence electron. So this NV negative is very important because many experimentally used these structures. So it have three energy states. One is ground state, and the second is metastable state, and third is excited state. So the excited state and ground state is called triplet because it have three transition. One is ms0, +1 and -1. Due to three levels it becomes triplets. And the metastable is just a singlet state where just ms equal to 0, and this also have spin up and spin down. So these are the three structures and three energy diagram of NV centers. What do you mean by degeneracy? Or actually degeneracy means two or more electrons have same energy level. Now let's come to the structure, and if we apply the magnetic field, what happen? So you can see that ground state to excited state, there is a line that is called 0 phonon line, and it have frequency 638 nanometer, and it's also equal to 1.94 electron volt. So ground state and excited state. And first if we now look at this point, and this point suggests that there is a zero field splitting. What do you mean by zero field splitting? Zero field splitting means the gap between the +1 and -1. No, it's a 0 and +-1. It's called zero field splitting. And at excited and ground state, the spin remain conserved, and there is also spin polarization occurs. Okay, so spin polarization means when you apply laser on nitrogen vacancy axis, it get excited, and when it comes back to its ground state, it produces a photon, and that is called photoluminescence. But when we apply magnetic field, then Zeeman effect occur. What do you mean by Zeeman effect? So Zeeman effect means the ms plus minus 1 becomes generated, and there is a gap between plus 1 and minus 1, and that is called Zeeman effect, and its value becomes 2 pi 28 gigahertz Tesla. So it's also a sad electron gyromagnetic ratio, and Bz is a magnetic field. So what happen when we apply a magnetic field? The spin dependent fluorescence level will be changed, and by manipulating, by observing that, we can observe that how defect occur, means how affect the spin fluorescence level. So it's form the basis of magnetic field sensing. So it's a strong application. It have strong application in magnetic field sensing. So now, what is the advantage of this nitrogen vacancy center? First of all, its main advantage is that it operates on a room temperature, at a room temperature. So it really useful for quantum sensing. Also, it can be used for qubits, and qubits are used in quantum computers. So, and there are many applications beside this. For example, we can use in nanocrystals and quantum metrology and ultrascale communication, like cryptography, like that. So hope you guys learn something from today lecture. So thank you very much. Please